The two things we are going to discuss today are arc length and sector area. Arc length is denoted using an S standing for arc length, and the arc is going to be the portion of the circumference basically that's intercepted by a specific angle. So for this particular circle that I have drawn here, our arc length could be this arc, or it could be this arc, and you won't know unless theta is clearly marked in there. So for this one, I'm going to go ahead and put theta here. So if this is the angle that they're talking about, then the arc, or my S, is this portion of my circle. So this would be S. It's a very basic formula. S equals R times theta. And whenever you do this, you're going to go ahead and multiply everything out. We want to make sure that theta is in radians. If theta is in degree to start with, you're going to have to convert it to radians, and then you'll go ahead and just plug it into your formula. Here's an example. So this first example, S equals R theta. You want to make sure that your theta is in radians. As you can see, ours is. So for this one, here's the angle that's marked. So they're talking about this big portion of the circumference. So you just take your radius, which is 14 centimeters, multiply it times your theta, and theta is in radians. So you just punch this all in your calculator. You end up with 73.3038, and since this measurement was in centimeters, then so is your arc length. So it takes on the unit of whatever your radius was in. For our second example, as you're looking at this, you first want to check, make sure this is in radians. That's the most common mistake I see students make on this. They just go ahead and multiply these two things together. But you have to make sure you first put your angle in radians. So we have our 225 degrees. We want to convert that. So we want to multiply it by pi over 180. So this gives us 5 pi over 4. So now we're ready to go. S equals R theta. S equals R, which they've given us is 15. Our theta that we're going to use is 5 pi over 4. And then it takes on the unit of the radius. Okay, sector area, same thing about the angle. You want to make sure that your theta is in radians, or else this formula doesn't work. So for this one, here's my theta. And then the sector area, you'll be able to see because they'll have it shaded in for you. But it's basically, instead of just being the arc length, of being a portion of the circumference, it's like a portion of the entire circle. So it's a portion of the area of the entire circle. So your formula, A equals 1/2 R squared theta, where theta is in radians. So again, it's just a formula. Once you know the formula, once you remember to put your theta in radians, you just plug it in. This one already has my theta in radians. So 1/2 times 13 squared times my theta, which is 5 pi over 6. So the area equals 221.2205 if I'm rounding centimeters. Last example, finding sector area. So see how they have this all outlined in dark? So we know that this is the area that we're talking about. So area equals 1/2 r squared theta. You want to make sure you put your theta into radians. So 75 over 1 times pi over 180. So this will give us 5 pi over 12. They give us r is 15 times 5 pi over 12. And then our radius was in meters, so our answer is in meters squared. I forgot that on this one. It's area, so you want to make sure you square your units. So, okay, that's it for today. If you have any questions, let me know.